Hello everyone, my name is Michelle Ardina and I will present to you my 10 to 15 minute video of mathematical logic. It's all about proof theory. So what is proof theory? So there are 4 basic proof techniques used in mathematics. We will just discuss the 4 basic. The first one, we have the direct proof, the proof by contradiction. Third is proof by induction, and the last is proof by contrapositive. So we'll talk about the direct proof first. So why we need to study the basic techniques in proof theory? Studying basic proof techniques develops crucial logical reasoning skills applicable far beyond mathematics. Mastering these techniques enhance problem-solving abilities and cultivates a deeper understanding of the structure and validity of arguments in any field. So here's an example. The sum of any 2 consecutive number is odd. So first, we need to define. First, an integer number n is even if and only if there exists an integer k, such n equals 2 times k. And second, we can define it as an integer number n is odd if and only if there exists an integer k such n equals 2 times k plus 1. We can also define it as 2 integers a and b are consecutive if and only if b equals a plus 1. Okay, so in direct proof, it's showing the truth or falsehood of a given statement by a straightforward answer. So let's explain this one. So direct proof. The example here is the sum of any 2 consecutive number is odd. So we need to assume a and b are consecutive. So it's given that b equals a plus 1. So a plus b equals a plus 1. So we simplify. So ab equals 2a plus 1. If we substitute a to, for example, 3 and b is 4, so 3 plus 4 is 7 equals 2 times, what's the value of a? It's 3, right? So 2 times 3 is 6 plus 1, it's also 7. So we can say that the statement is true. Like the 2 consecutive number is odd. 3 and 4 equals 7. So that's odd. Okay, next. So let's have proof by contradiction. Proof by contradiction is a form of proof that establishes the truth or the validity of the proposition by showing that assuming the proposition to be false leads to a contradiction. Okay, let's have the same example. Like the sum of any 2 consecutive number is odd. So first, we need to assume that a and b are consecutive. But because we use the contradiction, so we need to contradict the statement. So we assume also that a plus b is not odd. If a plus b is not odd, then there's no integer k such that a plus b equals 2 times k plus a. But a plus b equals a plus 1. And simplify it to a plus b equals 2 times a plus 1. So it shows that a and b is not equal to 2 times k plus 1. But a plus b equals 2 times a plus 1. We can conclude that a plus b is not odd. Okay, next. Proof by induction. So this is the third basic techniques in proof theory. So, proof by induction is a statement that is being proven true for all the natural number, which involves proving a base case and then showing that if the statement is true for a given number, it must also be true for the next number. So, the same example, the sum of any two consecutive number is odd. So, it's a little bit complex here. Assume that the proposition is true for some value of n, that the proposition is also true for n plus 1. So let's let the propositional form f of x be true when the sum of x and its successor is odd. So let's have the base case. Let's consider f of 1 is the sum of 1 plus 2 equals 3. So it's odd. It shows there exists some k belonging to set of integers such that 2k or 2 times k plus 1 equals 3. So the value of k here is 1. And also assume that f of x is true for some x. And then x plus 1 is odd. Since x plus 1 is odd, adding 2 to this value again gives an odd number. Okay, let's have the last basic techniques. We have proof by contrapositive. So, proof by contrapositive, it negates the hypothesis and conclusion while swapping the order of the hypothesis and the conclusion. Let's have the same example here. The sum of any two consecutive number is odd. So the statement here is if the sum a plus b is not odd, then a and b are not consecutive integers. So let's assume that the sum a plus b is not odd. There does not exist integer k such that a plus b equals 2 times k plus 1. So, a plus b equals k plus 1 does not hold for any integers k. But k plus 1 is the successor of k. So this implies that a and b cannot be consecutive. Okay, we're done with the 4 basic techniques in proof theory. So let's have this question. So how can proof theory be useful in our jobs, not only in mathematics? So it can be useful in a way of analyzing and understanding how we prove things. It's like a detective looking at the steps of a puzzle to see if they lead to a correct solution. For example, in software development, proof theory helps create reliable software by ensuring that program behaves as intended. Imagine a program that controls a self-driving car. Proof theory can help guarantee that if following traffic rules and avoid accidents. And also for lawyers or for legal reasoning, they also use proof theory to construct arguments and analyze evidence. They might use it to identify flaws in opponent's argument or to strengthen their own arguments or their own case. And also for artificial intelligence. Proof theory helps AI or artificial intelligence system understand and reason with information. This is essential for tasks like language translation, image recognition, and also decision making. For problem solving, if you have any problem solving, proof theory can help us break down complex problems into smaller, and then it can also help us identify potential errors in our reasoning. So proof theory overall give us tools to make sure our arguments and solutions are solid and reliable, just like a detective uses their tools to solve crimes. And that's it for my presentation, and I hope you like it. Thank you so much and have a wonderful day.